My name is John Burry. I am a specialist solutions architect, and it says principal solutions architect, but the full title is too long. Principal specialist solutions architect, it's a mouthful. Basically, all that means is they don't let me play with all the toys. They want me to go really deep on a handful of them. So my specialty is user engagement, and what user engagement basically means is people. It's not servers to servers, it's not networking, it's not security. I write the most insecure code at all, so they won't put me over there. But it is about people. It's about consumers, and that's IoT devices, that's mail, that's messages, that's text, that's push from mobile. It's when a customer is engaging with a product or a service and how that company works with that engagement. So the discussion here is going to be connected home devices and customer-centric connected home devices, and talking about IoT, talking about the different services that we use that make some really great solutions here. This is a lot of fun for me, this topic. It's near and dear to all of us. Every single person in this room, every single person in reInvent in the world is touching their devices, connected with services and so forth. And so everything we talk about applies to everyone in this room, whether you're on the end of the receiver or you're producing solutions. So this is our topic today. We're going to go through why this is important. I'm not going to talk down to you, and I'm not going to teach you like, this is what you don't know. My point of framing it this way is why we think it's important and how AWS has created its services with this mindset. How we're coming at it, which is the point. Same thing with next generation customer centricity. That's a mouthful, but the point is how we are looking at this and why our services are built the way they are. Informed by a lot of our businesses, including the Amazon.com massive amount of activity there. Then how AWS customers deliver innovative connected home services, experiences, we'll talk about that. How AWS improves business outcomes, AWS services overall, and then we'll get to the good stuff. I have a few demos. These demos are code heavy. I'm going to walk you through solutions. So I don't expect you to be a coder. As a matter of fact, it's all real simple stuff, and that's really the point of it. The web services themselves are meant to be stitched together with very lightweight code. You can get as crazy as you want to. And I'll walk through how things work and the logic behind it. Also, I'll make myself available at the end of the session if you have any questions on anything and want to go deeper on something. So why is this important? Why has Amazon built things the way they have? This quote on the internet that I found, I love this quote because I'm not going to read it all. You guys can read it, but the key is the last highlighted yellow line. Basically, smart homes, other connected products, they're all very important. And a company that ignores this area is like ignoring the internet at the turn of the century. Ones that dismiss the Internet of Things risk getting left behind. And we know those classic stories about the companies that didn't take the internet seriously or didn't take something seriously about as the internet evolved. And we've all been there. Every single company in one form or another has made a bet and has been wrong. That's just how things are, right? But the point is, some of these bets are bigger than others, and this is one of those really big areas. It's massive. The numbers are overwhelming. When we look at numbers of PCs, we look at numbers of tablets, mobile phones, those are big numbers. But when we talk about smart home numbers and devices in smart homes, 940 million smart home devices expected to be shipped worldwide by 2022. That's on top of what's already out there, and that's just going to explode even further. Now think about it. Every single person in this room has at least one connected device in their home. You know we have tons of them. I can confidently say every single person in this room has a ton of them. The other day I turned on my Wi-Fi sniffer software and looked at all the devices that were on my home network, and this is my area, so I love it, but I'm not that crazy about it. We kind of, keep our head, down to earth on wiring things up. But I had like 33 devices wired up, which sounds to contradict exactly what I just said, but it's mind-boggling. Everything from your internet-connected media devices to your security devices, if you have cameras and so forth, it's crazy how many devices there are. This is huge. Now, the point isn't about the type of device. The point is about the interactions we're having with so many of them. And as developers of both device hardware and the services that hardware needs to use, we have to think about this entire ecosystem and how our consumers are looking at this entire ecosystem and how we're building tools to make your success as possible as can be. Meaning that we're trying to look at this not just like, look how fast it is, look how secure it is. We're really trying to make it so that you can build tools that make your devices more comfortable for your users, so that they're happier to use your devices. And this is what next generation customer centricity is. So next generation customer centricity, as defined by Amazon Web Services. Again, I'm not telling you something you don't know. I'm telling you how we look at it. Integrated devices that respond to commands quickly, super fast, and accurately. They're smart. We have confidence in them. With or without stable cloud connections. So disconnected and intermittent connections, devices that are disconnected periodically or intermittent connections. And the key is this last one, get better with time. So when there are 3 different products, product A, product B, product C, from 3 different manufacturers, all the same type of a product, let's say they're a photo product. And product A and product B work pretty well similar to each other. Product C, every week, every month, it seems to have more features, it seems to get smarter, it seems to know you more. Which do you think you're going to choose? It's human nature. We're going to want the one that gets better over time. And how do we get better over time? And that's what part of this talk is about. So the different devices that we have, you can think of them. Obviously, we have voice control. Lots of different manufacturers are making those. Of course, you know, we do as well. Really valuable devices in our life, more and more so. I was not really thinking this would be huge. I thought it was cool. I didn't realize how huge it would be and how personally I use multiple services all day long this way. Interoperability between devices through hubs, meaning that you can actually have multiple devices, potentially from different vendors, all talking to each other through hubs. They don't have to be Wi-Fi hubs. They can be other types of hubs too. Now, the customer experiences. Really, really good customer experiences. That's critical. And to be clear, we all know that. You know, the customer experience is gold. It needs to be golden for a person to keep using the device. But I'm going to go beyond the UI, not what the graphic designers have thought of. I'm going to talk about the experience and driving the get smarter with time. And then, of course, ease of use, which falls into that category. So how are our customers doing this? So to take a step back and let's take a living room here in home automation and the various AWS services that we have. And actually, I'm going to go into a few of these as I give my demos, not all of them though. But let me walk through what we have. First of all, we have smart TVs. A number of manufacturers now are directly connecting to AWS IoT Core. When the device gets on Wi-Fi, it's streaming data across IoT Core. That streaming data is really, really valuable data to understand which features are being used, which features are not being used, how to invest more in both education, invest more in new features going forward. Device management with Device Defender and AWS IoT Analytics. Again, this data coming across the wire and understanding it. And I'll just jump ahead. This is a huge area I'm going to be talking about in a bit. We have services like, or solutions like Amazon Free RTOS, which provides a very, very powerful operating system for small devices and can connect directly to AWS IoT. And IoT Greengrass, where you can run Lambda at the edge. Pretty incredible. I thought Greengrass was magic when I first heard about it. Lambda functions running on devices, not connected to AWS. That's amazing. Here are different types of examples of implementations. On the left-hand side, free RTOS could be in door locks, light bulbs, appliances, whether they're large appliances like washing machines or small appliances like a coffee machine I just bought that's connected to the internet. I have one of those Alexa microwaves, which sounds ridiculous, and it really is, but it's so ridiculous it's awesome. I put a bag of popcorn in and I say, Alexa, microwave the popcorn. And then if I'm walking around and I think, you know, that's taking too long, that popcorn's gonna get burnt. You know, you always do that. You don't trust the machine always. You can go, Alexa, stop, before you can get to the machine. It's awesome. I love that. I'm not trying to sell Alexa microwaves. I'm just telling you that this type of integration we're getting nowadays. So home controller or Wi-Fi routers, Greengrass, again, this is Lambda at the edge. This is a actual function running locally, returning data back to the cloud when it is connected or when it needs to. And then security cameras are an example. So these all connect from your home to the cloud, and on the right-hand side, I'm gonna talk about the middle in a second. On the right-hand side, you have things that aren't necessarily traditional IoT devices, but mobile applications, potentially using MQTT to talk to AWS IoT. The customer interaction with various devices, dashboards that we have, Alexa devices. Again, Alexa devices are kind of this hybrid. They're not necessarily IoT devices in all cases, but they have IoT applications. And in the middle here, on the left-hand side of this white box are core AWS IoT services. There's a lot more than this, by the way. And it's growing, amazingly growing. This is one of our most active businesses in AWS. Again, back to those numbers. This area is huge, and there's been a number of announcements as well to look into this week, which is exciting. And then, of course, the AWS IoT services talk to the larger set of AWS services, which have also grown this week. So there's going to be a test after this class of all the announcements, and I certainly wouldn't pass it. I have a lot of study to do next week. Okay, so let's get to the good stuff. I'm going to flip over to my notebook right now and start doing some demos. Okay, in the screen here, let me just kind of zoom in. I have a fictitious device from a fictitious company I'm doing. I'm calling it Maximus, and the reason why it has a heart is because one of the goals of this device is it is so well developed, the solution hits home so well to my consumers that they love it. They appreciate what Maximus does in their life, and I don't, in this talk, care what Maximus is. You can imagine what you think this device is. It's just some fictional device. The reason I'm making a fictional device like this is because I'm going to walk through logically what happens. I've made the device, and the talk isn't important about, again, what the device is, but I've made the device, I'm connecting it up to AWS IoT, I'm collecting data from the device, and the services I'm going to use to try and make my relationship with my consumers as good as it can be. Okay. Maximus is also a device. The heart has another meaning. It's a device that is worried. It's worried about being abandoned. And the reason I'm talking about this is critical. Before AWS IoT, my personal experience was in mobile. And mobile applications, as you all know and love and hate, mobile applications, people will abandon mobile applications faster than anything. You'll download an app from the App Store, you'll play with it once. If it's a little too slow to start up, or the next screen looks a little funky, you don't like the design, boom, it's gone. You won't do that as quickly with desktop applications. It's interesting psychologically. There's a little bit more of slack you give a desktop application, but you do not give that to a mobile application. You just throw it away or ignore it or abandon it. So that's really painful for mobile developers when you put a lot of time into it. It's even worse for device manufacturers. If you're here thinking about connected home and you're going to build connected home solutions, and you are in fact deploying one, whether you're on the hardware or software side, if your consumer abandons your device because it isn't all that to them, or they just forget about it because we go back to all of the connected devices in our house, that is painful. That's death to a company. So my little startup Maximus, I don't want our consumer to abandon. So our needy little device is going to do everything it can to be out there. So let's go forward with this. Okay, so I've got a number of spaces in my Mac set up here at the top. I'm going to try and not give you whiplash as I move around. So a couple things I'm going to do here. One is, as I go between services, I'm going to start documenting in real time. So I'm going to zoom out a little bit. This is a mind map app. And so I can just go ahead and start writing out nodes so you can watch the flow of what I'm doing here. So first of all, we want Maximus to connect to AWS because it's going to use all the services. So the way it connects to AWS is it typically is going to connect to AWS IoT. And it's going to do this across the wire. And the way it does this typically is either with code that I develop on Maximus, or I just go ahead and use the AWS IoT SDK installed on Maximus. And this will communicate. I wire it up, set up the certificates. There's a whole process, and this talk isn't about that specifically. You can go into other talks in detail and look at the videos or look online. This talk is, again, a layer above this to look at the bigger picture. But once I've got the SDK installed, I am then talking to the AWS IoT across the net. And this is typically what happens. In this UI here, actually, I'm going to turn on a highlighter. What I have highlighted here is on the device, and then the third box on the right is in the cloud, okay? Pretty obvious stuff, right? Super simple. So I'm starting with simple because what I'm going to do here, in order to do the simulation I'm going to show you, since Maximus doesn't exist on this stage, I'm going to simulate Maximus. And the way I'm going to do this is I am going to, well, I'll show you. Let me pop into my next thing. I'm going to cheat It's a great way to prototype. I'm going to use Alexa. Not really an Alexa. I'm going to use the Alexa Skills Kit, which is all software-based, software version of Alexa. This gives me an interface right out the bat. I don't have to think about my design, my hardware. I can talk to my device and leverage Alexa. Again, I don't have to be committed to using this when I finally ship my device. It doesn't have to use Alexa at all. I'm just using Alexa to help me prototype. Okay, so I've got Alexa skill. If you see here, I have IoT device engagement. I'm going to go ahead and open up this skill. And I've gone through the process of setting up invocations, intents, and slots, build a model. It's not Alexa talk, but the key concept is I've created a software implementation of Alexa, and I have called it Maximus Device. Whoops, sorry about flying around there. Or at least the invocation name is Maximus Device. So let's test this out. If I go into test, and over here, I've got this type or click and hold the mic. So if you're in some place where you can't talk and you're in an office, you can just type in the command. But I don't know if the audio is working here. Did we test this for audio? Let's see what happens. Alexa, I can't laugh when I do this. That's no content comes back when you laugh. Alexa, start Maximus Device.
Thank you for engaging with Maximus Device. I will report back that I have not been abandoned.
Okay, simple stuff, right? So what we've done, though, is we've simulated the device has connected to the cloud. And what's it connected to? Well, it's connected to a Lambda function. If you haven't used the skills kit, you have really cool opportunity here. If I go into the build tab and go down here and go to endpoint, I have set up a Lambda function as an endpoint. Simple stuff, and the documentation will walk you through this really easily. You can get this done in a few minutes. But let me show you that Lambda function. So going back up here, here's the function. I call it serverless Maximus. It's a name. I deployed it with a CloudFormation template. I actually cheated, and I used the skill color kit for Alexa. Alexa has all these templates that you can use for skills. Do that. Don't start from scratch. Install one of the templates and then go in and edit the code for prototyping. Don't waste your time. So I've got the skills color kit here, and here's you can see right on the screen. Thank you for engaging with Maximus Device as the speech output. Really simple, okay? Now that we have a Lambda function, what I've created is this, going back to this. So we have Alexa skills kit, ask, clever acronym, whoever thought of that one. So Alexa skills kit is invoking a Lambda function, okay? The Lambda function is, all of these together is my device, simulated, okay? Now let's talk about AWS IoT. Let's connect to that. So logically, what happens in this, and going back to my third thing, let's go into AWS IoT. So I've set up already a Maximus device. If I go in here to manage, I've got a number of devices and various demos I've done. And so here's the Maximus device. This is a thing in AWS IoT. If you're not familiar with this, take a look at the other sessions. They will take you right into everything nitty-gritty about making things, but the concept is it's a virtual representation of my device in AWS IoT. And the device can talk to it and engage with it. And one of the things a thing has is what's called a shadow. And so let me click on shadow here, and a shadow is a representation of the state of my physical device that I can store up in the cloud. The value of a shadow, which is really super cool, is if without a shadow, my device I could ping my device from the cloud and say, hey, what's your state? Is your light switch off and on? Is your screen showing a photo right now? What are you doing? But if there's disconnections, you want the state to be stored somewhere where the cloud can say, well, what was the last known state? Which is what you see up here, desired, reported, and what's the delta between desired and reported. By changing the state in the cloud, you can change the state without having to always talk to the device. And when the device phones home, it can get its state. So here's the trick. I have a couple things, last device connect time and last device engagement. These are two attributes that my Maximus device has. And when I change this, let's say I've got to click on edit to change. When I change these, and the Maximus device Lambda function, the one that just said, thank you for engaging, I'll report back. Well, let's say last device engagement is a 1. The user has used a feature. Doesn't matter what number I'm putting here, by the way. That's not part of what I'm trying to show. So I just changed it. And when I changed it, other stuff has just lit up. And so those of you who know what AWS IoT is and how it works, you know what I'm going to talk about already. I've created a rule. And the rule does something. A rule, if I go over here to go back, actually, and go down to Act, I have a Maximus Device Engagement rule right here. This Maximus Device Engagement rule is just watching the shadow, doing a query, really. Select from the path that is the Maximus device shadow, and when that shadow is updated, this is referred to as MQTT topic, mouthful. Whenever that shadow is updated, do something. That something is going to be run a Lambda function, another one. The Lambda function is doing this. Yeah, here we go. The Lambda function is going to send a message to my device, and I'm simulating that with an SMS message here. So what I've got is, in my Mac, I've got Messenger open, or Messages, I think, not Messenger. And this is connected to my phone. And so whenever I get a text message, it'll come in here. So if I go back to my thing state, okay, so there's my rule. Again, I'm flipping around, so I want to make sure that I'm not creating too much whiplash. So go back to Manage, My Thing, Maximus Device, and go to my shadow. So I have the devices there, and interestingly enough, I have the text message here, but it hasn't shown on my computer. So unfortunately, I can't show it to you. For some reason, we're not connected. It usually is, but we have a connection issue. But the device is reported back. So here's how that happens. Going back in, well, there it is, just came in as I was standing there, or sorry, talking. So there were actually 3 shadow updates that occurred. So each shadow update executes the rule, executes the Lambda function. The Lambda function calls a service called Pinpoint, which I'll talk about in a second. Pinpoint is a user engagement service that allows us to send messages. Remember, I told you this domain I focus on with IoT and user engagement. So I told Pinpoint, send a text message to a phone number associated with the owner of this pretend Maximus device. So it says, hi, John, check out our new blog post, Secrets of Maximus that you may not be aware of. The reason it did that is because we just set up a rule. I did something on the device, and it gave me this notice on my phone. Okay, I've engaged with it. So here's the logic behind this. Let me pop into Lambda. Oh, got Lambda up here. Let me go back to functions. And I have a Maximus device engagement function. And this is super, super simple stuff. Again, let me just go ahead and make the screen full screen, increase my font size. Here's the function. I'll highlight it this way too. So I create a variable of a message. Hi, John, checked our new blog post. That's the text message. And then I call a function called send, completely misspelled so that you would go what and catch it and remember this and never forget it. Send pinpoint, so actually pinpoint. Send pinpoint message is what it's supposed to be. And down below is the message call. It's very simple. I call the pinpoint client, call send message, and I give it a JSON body, which is a very simple, I want an SMS message to this phone number, and pass in the variable message, and boom, it goes. Every single one of you guys can do this today, by the way. You don't have to sign up and get authorization. You can start sending text messages from AWS accounts. Very cool. Now, there's a limitation, to be clear, so you're not spammers. It's $1 per month you can spend, which is about 160 messages in the US, different prices for different locations. But you fill out a ticket if you want full access. All you have to do is explain what you're doing. And the AWS team managing Pinpoint will approve you or not. It's just to make sure you're legitimate, not some fly-by-night, someone who wants to spam advertisements. Okay, so here's the logic, going back to this. So now what we have, I'm going to start a new node. Let's say AWS IoT. And what I'm going to do is float this out so it's not part of the Maximus Core. So in yellow there is the Maximus Core device simulation. So the Maximus device, I'm actually going to just draw a bridge between these two. Okay. And I'll put this over here. Okay. So AWS IoT now is doing this. And the IoT Core, I'll be clear. IoT Core, shadow change, rule, watches the shadow change, calls a Lambda function. Lambda function calls Pinpoint. I'm a terrible typist. Pinpoint sends an SMS. That seems complex, but actually it's not. This could all be wired up in about the time that I took to type that. That's how bad a typist I am. No, not really, but in a few minutes. As a matter of fact, that demo I did on the shuttle while we were going back and forth here. It's just simple stuff. IoT Core, again, a shadow change. You have a rule that watches the shadow change. This is an MQTT path in it. And it says, if there's a change to the shadow, I want this Lambda function to run. The Lambda function has code, has this very simple code that says, send a Pinpoint message. Let me debug my thing in real time here. And there, saved. So now it sends a Pinpoint message using, you can see there's not complex code there at all. That's the power of the AWS services, is you think of it as the code is really just glue to script features that you want to turn on between the services. That is so awesome. Okay, nothing really heavy and monolithic. And that's the logic. Pinpoint will then send an SMS. Let me show you Pinpoint real quick because I'm going to come back to it in my second part of my demo, my second demo here. Let's see, I've got Pinpoint, I believe, over here. Nope, that's step functions. We're going to go back to that. There we are. I'm going to all of those services, by the way, in my next demo. There's a lot here. So Pinpoint, engage your customers across multiple channels. It's actually got email, text message, mobile push, and voice. So you can do robocalls. And the cool part about this is the same JSON call to send a message, the same one I just said to send an actual SMS message can be changed to send other. So for example, if I go into here and say SMS message, I could say email. And then likely there's going to be different JSON attributes I fill out, but the cool part about it is that simple to switch channels. So it's an omni-channel tool. A person can say, I would prefer to be contacted in SMS. Another can say, I'd prefer to be contacted in email. Or mobile push, pop-ups on your mobile. And your code can be the same. And just by the user's preference, make the changes in the JSON. That's pretty cool. So, so that's Pinpoint. It's again, a user engagement tool. And let's go into it. If I click Manage Projects, I have a project here called IoT Device Engagement. So in Pinpoint, if I go to Settings, you can see that I've enabled the SMS and voice channel. So that Lambda function call works. I've called this particular project that's called IoT Engagement Project, whatever, and I've turned on SMS and voice, and when I send that JSON body, send a message, it works. But I could also turn on email. I could configure push notifications, and I have analytics that come in for the Pinpoint and so forth. Now, I'm going to move quickly past Pinpoint because I want to get back to the key concepts of the IoT device. Pinpoint is a last part of the process to engage with the customer and send a message to them, so keep that in mind. Okay, back to my mind map. Let's zoom out a bit so we can see the whole big picture. Okay, IoT Core, this big picture. Someone does something on Maximus, and because this is a simulation, we really don't need this. We'll do this, AWS IoT SDK. In production, this is what's really going to look like. So the SDK, and by the way, the SDK is optional. You can write your own code to interface with AWS IoT. Okay, let's fit that all in one if we can. All right, I engage with Maximus. The AWS IoT sends a signal, sends a MQTT topic update across the wire to AWS IoT Core. That updates the shadow. A rule watches the shadow change. Lambda function triggers Pinpoint and SMS. Let's do something different now. Let's get into where I'm really going to start to get preachy, and I apologize in advance. Data and ML, because that's the key, really, of this. How do you, I talked a big talk when I started the presentation, talking about you want to make sure that your users have an affinity for your devices and they don't abandon them because of all the effort you put into them, right? How do you do that? There's a lot of different ways to do it, but one of the most powerful ways, one of the ways that we've learned, Amazon.com has learned, and when you buy our devices, and to be clear, everyone else in the industry does, is we use ML to watch what you're doing. And with that, we are able to see patterns and make predictions. One of the things that we have is if you go to AWS Solutions, you'll see some solutions that are Pinpoint focused, and there's some that are IoT focused as well, but we call this area predictive user engagement. We want to predict what you're going to do. So I'm going to use SageMaker. SageMaker is one of our most powerful ML services, and we're going to watch data that comes across the wire. So in this demo, I have a SageMaker notebook called Predictive Churn Notebook Instance. We are going to do predictive analysis to try and predict churn. And by definition, in this case, churn means a user is starting to interact with Maximus in a way that's risking their relationship with Maximus. Because when we see that there's this heartbeat of activity, people are playing with our IoT devices, and then boom, they stop engaging with it. They forgot about it. They unplug it and they put it in the closet or a drawer somewhere. That has a pattern. And the ML services can watch engagement and look for it and see that pattern. And we can predict that John, me, is going to stop using Maximus pretty soon. So what do? We do an Hail Mary or whatever to try and engage with that customer and try and interact and do an intervention. I already showed you Pinpoint. That's one of the ways we can do an intervention. You see this, by the way. It sounds kind of crazy what I'm painting, possibly, but you see this every day, every single one of you in your pocket. You will get mobile pop-ups from apps, and those mobile pop-ups are sometimes very annoying. A lot of us turn off notifications because of them. But the reason why those exist, and the reason why there's more and more of them, is because this is the practice that these companies are doing. They want you to re-engage with their apps and not forget about them. And so remember when I mentioned the mobile developers get sad when you forget them? Same with AWS IoT devices, but fewer and fewer companies have done this on IoT devices. And we're starting to do this more and more now. The goal here is to watch the data, predict a churn, interact with the customer before churn happens, bring them back to your device. And that's what we're going to do here. So we have this notebook that looks at data. And to be clear, let me go ahead and open up Jupyter Notebook. If you're not familiar with ML, this is all easy stuff to learn. But basically, we have a Python. We have data, and we have Python logic here that interacts with this data. In this data, we have device engagement data.csv. So for this demo, it's a simple CSV file. And you can see the fields at the top of the CSV here. The key are last device connect and last device engagement. Those happen to be the same in my shadow. Those same two fields I just played with that triggered that message. And here's some sample data. The data is not important. Just keep in mind that the concept is the wiring up of how we can see this stuff and what we can do with it. So this is all just generated test data. So the data comes in, and how does it come in? Well, let's go back to this. Again, this could be where the test data comes in. Logically, I would recommend using AWS Analytics, IoT Analytics. So if I go back to, I got IoT over here. If I go back to AWS IoT, as a matter of fact, I go back to the console, scroll down all the way here, I have the Internet of Things area of the console. And you'll notice here in IoT Analytics, I go into a very cool service that provides scalable, fully managed analytics that will take stream of interaction data from your device, not just shadow changes, because that's a kind of a test, that's valuable, but what you really want to watch is all of the changes that are happening in your device. It's a lot of data. So AWS Analytics will automatically bring this data in. We'll connect up to AWS IoT Core, so IoT Core will send it. And then you can do things such as, if I click on notebooks, look at that. This predictive churn notebook instance happens to be the exact same thing as I've got over here in SageMaker. Predictive churn notebook instance. So in essence, basically what's happening is AWS IoT is wrapping SageMaker for you in IoT Analytics. So you get the power of this fully scalable service that will allow you to stream analytics into AWS and then send that on your behalf to SageMaker for you when you wire it up. Again, it's real simple to use, but let me show you how this works. So back in SageMaker, when I've got my notebook already open, So I've opened Jupyter, so that should be over here somewhere. Actually, I'll just do this. Yeah, I have it there. So I have the device engagement data I showed you. So let's go ahead and open up the IoT device engagement Python component that is going to train the ML model in SageMaker against my user data. This solution, by the way, we have a version of the solution that is predicting email churn. This is currently available online. If you Google AWS solutions, you'll go to the solutions website that has a whole library of tons of solutions. All this code I'm showing you today is available there. Now, when I say all this code, I'll be clear. It's specific to a email solution. I've wired it up for IoT. The wiring up that I've done in IoT, you guys could do yourself pretty quickly, and we probably may end up updating it with a second solution for IoT shortly. But I'm sure you guys can figure this out yourself, what I'm doing, because it's not complex. I like to joke, if I can do it, you guys, anyone can do it. So, because I'm not really a good developer at all. And by the way, I didn't develop this. This solution was developed by one of my colleagues, Ryan Lowe. Really sharp guy, and he gets credit for developing this, which is awesome. Okay, so this Python is just going to basically look at the data and train the model. So let's just go ahead, and I'm not going to walk you through the code on this. I'm just going to run it. So we're going to train a model right now in real time on this sample data. So the training job has started, and I'm going to come back to it, because it takes a few minutes for the train job. It doesn't have to happen every day. You start it just once. When this training job is done, we're going to go over to step functions. So the rest of this solution has logic that runs once a day. It doesn't make sense to run it more than once a day because you're just going to look for customers who are likely to churn. That's not something you need to do in real time. You don't want to do it hourly. You don't want to do it half a day. Just every 24 hours makes sense. So we've got some step functions here set up. So I'm going to click Get Started. Actually, go back to my state machines. We have a state machine, to be more accurate, set up that will do a daily churn list state machine. So once the SageMaker ML model has been trained, it can take in the new data that AWS IoT sends it every day. And then it can run this state machine against that data. And this state machine is going to automatically give us a list of owners of Maximus that we need to hug, so to speak, okay, with the AWS data. So I can't run the state machine until the model's trained and finished. So let's go back and see where we are with that. Still going, launching requested ML instances. So while this is happening, let's update my map here. So I have AWS IoT Analytics, and so this data comes into, in this case, we're going to go to SageMaker. They're going to have a state machine, which, by the way, if you're not familiar with state machines, just think of it as Lambda functions. Lambda functions with pixie dust on them. No, basically, you can put Lambda functions together that run at scheduled times, and also, when the state machine runs, you can see, will wait. And you don't pay for the wait. So a little bit of a tip here. If you guys code and work with Lambda functions and you haven't worked with state machines, highly recommend you play with them because they're cheaper. They're a lot cheaper if you code them right. And so here's how it works. Lambda rocks. Lambda is code that runs without having to set up a server. You just give AWS the code, and it runs the code. It finds a server, runs the code does things, and then it dereses. You only pay for the time the code runs. That's awesome. But sometimes your code may need to do an API call to another service somewhere, inside or outside AWS, and there may be latency on that other service. You might do a massive query or something. The problem is, if you have to wait, you're paying for those milliseconds of waiting. Now, Lambda is super cheap to begin with, but at scale, if you're a Netflix or something that runs on Lambda functions, and you're scaling massive amounts of Lambda functions, every little millisecond counts. So state machines allow you to say, while I'm waiting, you just turn off the function, basically. And then you bring it up later when the state has changed. You don't have to pay for things, so it's a lot cheaper. You don't have to pay for that period, to be clear. Okay, so let's, I'm just going to switch between my screens here. So let's go back to see if our training is done. Training completed, great. You'll get some errors, by the way, the first time you train. That's not an issue whatsoever. But the training's now been completed, so I can go to my state machines. Before I do, I need to show you something. The output of the state machine is going to go to Pinpoint. So I'm back in Pinpoint now. I'm on the IoT device engagement, what's called a project in Pinpoint. Now again, I'm going through a lot of topics real quickly. Pinpoint's that service that allows me to send a message to a user. In this project, I have what's called segments. And segments are lists of users that I want to send messages to. And you can see it's empty. It says, that font's kind of small, but it says you haven't created any segments yet. You get where this is going. When that step function runs, its job is to talk to Pinpoint and make segments for me. Segments of users that are a concern. So let's start that. Okay, I don't have any right now. If I go back to my step function and click start execution, okay, the function's running, the state machine's running. Now look at this, this is kind of cool. While it runs, I have this visual workflow. Sorry, zoom in a bit. The colors on this workflow are showing me what is going on. It started, clean start, export Pinpoint endpoints, export wait. I'm not having to pay for the time that the export happens. Keep this in mind. Basically, I'm taking data out of Pinpoint. The way this was written is if there already is data, it's going to pull it out and use that data to train on as well, but there isn't at the moment, so it's not important. But when you do exports, sometimes there can be a delay. So we check the export status. We check to see if the export's finished. If it's not finished, coming down here, we're going to check if the export failed for one reason or another. If there's nothing to import, we're going to end. I don't want to give you whiplash by going through everything, but the concept here is your state machine can have all these different conditions, and if a condition is being like a query wait, you're not paying for that. Rather than write that into code in your Lambda function, which a Lambda function can run for, I think it's 15 minutes now. Doesn't make sense for a Lambda function to say, I'll just sit here and wait for 5 minutes while something finishes. That was before state machines, you had to do that. So this is a great solution now. Okay, so we'll wait for this to finish. When it does, this running will be done. One of the things I do need to do for this is refresh the page because it is longer than the execution status timer updates. Okay, that'll come back in about 30 seconds probably and be finished. So we've got SageMaker, state machine. State machine is going to Pinpoint. Pinpoint is creating inside Pinpoint a segment of people to talk to, and from that segment, we can send out SMSs, okay, to them. Another way to think of this is we can do this. If I delete Pinpoint, come back up here, and draw a connector. So the IoT Analytics is taking the data coming from the device, doing this churn analysis. State machine is taking the output of it, creating a Pinpoint segment, and sending off an SMS. So to do this, to be actually accurate, and I'll show you all these parts as I build it, we're going to build a segment, then a campaign, then SMS. And what's the difference between the two? A segment is a list of people, a campaign is a message, and a date and time that you want to send it to them. So we don't necessarily want to send off a message the moment the state machine finishes. Maybe, but it doesn't always make sense. You might have further analysis that says 9 a.m. is the best time to contact a particular user. It's an important thing, actually. Pinpoint is, you're able to do this type of analysis with Pinpoint to say, when should I send a message, and over what channel again? It doesn't have to be an SMS. It could be a push, mail, and so forth. But that campaign is where we define the package up, the segment, the message, and when. Okay, so let me show you that. Popping into the state machine, still running. And so in the meantime, I'm going to pop into show you the campaigns and how they work. As a matter of fact, I cannot, because a campaign requires a segment to begin. So because I've set everything up with no segments, because I want the state machine to make one, I'm going to wait till it's done. Let's see if I can refresh. almost done. In the meantime, let me show you this concept that's pretty cool in Pinpoint. You've got campaigns and journeys. I mentioned a campaign is when you take a message, a segment, a message, and a date and time. A journey is like that, but a journey is where you can create a workflow that is if then do that with a message. So basically the concept is you can email a user. If they open the email, then you can go ahead and send them another one. If they didn't after a period of time, you branch off to plan B. You do something else. If they clicked a link, for example, you can go to another plan, and you can follow this logical flow as to if a user's done this, then I want to do this. And it can be a very sophisticated journey that lasts over a long period of time. It's kind of neat. It's used primarily, I shouldn't say primarily, it's used for marketing a lot, but not primarily. It's used for customer engagement. So this very type of thing we're talking about, where we take the IoT data, we've got all the connectivity, we analyze the data, and amongst all the things we figure out that we need to talk to the customer about something. And this is, using Pinpoint, how we do it. By the way, this is how Amazon.com does it. So when Amazon's talked to you, when you got a text message, you got a shipment status, Pinpoint is likely being used for that. We were very busy on Black Friday and Cyber Monday, so with this service. Okay, let's go back to segments. Boom, there's my segment. So the step function has finished, and now I have a segment called predicted to churn. These are people who are possibly going to stop using Maximus because our ML model that we trained is looking at the analytics data, and we go, uh-oh, we got a problem. So if I look at this segment, it just shows me quite simply there are 9 people. Again, it's just sample data, so the number isn't important, but it does tell me there are 9 records. I've got to contact these people. So now that I have a segment, I can create a campaign. So I go into campaigns, click create, and I'm going to say, come back to us. Of course, that's not the title they see, but this is what internally we're going to refer to it as. I can do a standard or a test campaign where I can test different messages and see the response rates, an A/B test. It's kind of neat. But I'll just do standard SMS, click next, choose my segment of predicted to churn on my IoT device, click next, and then set out the message. When you send SMS messages, you choose transactional or promotional. That's the carriers need to know that. They prioritize resources as to how SMS messages go out. So I'll say this is promotional. Transactional, if you ever do this, be careful about transactional. You don't want to get in trouble with the carriers. If you do something that is promotional and you say transactional, they'll overlook it most often. But at large scale, they'll go, no. We got to talk. So you don't want to get in trouble so you can't send a message. That's not an AWS thing, that's the carriers. So I'm going to use a template. I have set up a template which is basically just a pre-written message that you can save. And you can see here's my message. Hi, attribute.firstname, check out our new blog post, secrets of Maximus that you may not be aware of. And this is typically how this kind of stuff is done. It isn't come back to us. You don't want to appear needy. Like, please use us more. We've noticed you're not using us. No, and this is how it becomes really effective. You say, it's education. Did you know that these features exist? And your analytics data coming across can show you that's the features that customers are using and which ones they aren't using. And so you can get a bit more sophisticated than my demo. You can have different segments, features, people who share photos on the Maximus device, people who've never shared photos on the Maximus device, people who have never understood that Maximus can set microwave popcorn times, that kind of a thing. The exposure of these features is how we reach out and bring them back. Okay? So a couple more things I'm going to wrap up with here. Going back to my mind map. So Pinpoint is now being used to segment, campaign, and SMS. So let me back up for a second and talk about the ecosystem here. With AWS IoT Core and IoT Analytics, as a matter of fact, with every single component here, we have completely serverless architecture with all these AWS services. We're not using EC2, we're not spinning up instances, we're not having to think about scale. So the beauty of this is we are able to build at low profile, and then as the data increases, as we get really popular and someone has promoted our device on Twitter, and we have 1 million customers now, the same architecture works for 1 to 1 million. 10 million, what have you. Let me show you one more ML service that is a spectacular ML service that is built on top of SageMaker and solves a very specific situation. So this is called Amazon Personalize. Personalize is another service that we can use to solve a problem like we just tried to solve with the Maximus churn. But it's like in the kitchen, it's one specific tool. It's like a knife, a very, very sharp knife. Not really good to whip your whipped cream with it or whatever, but it works really good at cutting certain, your steak and so forth. What it does, it's a real-time personalization recommendation service. So as your IoT Analytics data comes across, you can take a look at the activity your customers are doing and decide to create recommendations as to what activity they should be doing or they would most likely like to do. This is the recommendation engine that Amazon.com uses. When you shop around Amazon.com and you put items in your cart, or actually not even that, when you just click on items and you look at them, Amazon is tracking you in real time. It's not trying to be menacing, it's trying to be helpful. It's trying to create that affinity, which of course increases the conversions. And every company that has a sophisticated website is doing this in one form or another. Amazon has built Personalize and the logic behind Personalize out over 20 years because it is the same engine, or at least replicated as a copy of what Amazon.com has. And the models, the ML models that Amazon's been using are automatically made available to you in Personalize. That's pretty cool. So it's something that I would recommend when you have a consumer device, because Personalize is all about consumers. So that's what connected home is. We're not talking about factory devices. We're not talking about bots that analyze the weather or things like that. We're talking about something the user interacts with. And Personalize is about the user, individual person, a human being. So here's how it works. There's a simple graph here that I zoom into and hopefully it can be read. So basically, you bring in data, just like SageMaker. Now, I mentioned before, and it's a key concept to really understand, this is built on top of SageMaker. So when you're using this, you're using SageMaker, and you can do the same thing in SageMaker, but this handles the heavy lifting for you. So on the top left, Amazon S3, you can bring in your data. Now this is AWS IoT, can talk to it. So AWS IoT can bring in data into Personalize. You can have a front end, whether it's a mobile app, a web app, or whether it's a function like a Lambda function that will send something to your IoT device and change something on its display. But somewhere you have a front end where the output of Personalize sends recommendations. For those of you who have seen the Echo Show, you know the Echo Show, it's the Echo with the screen on it, and it rotates information on it. Sometimes it's news articles, sometimes it's, hey, try this out. And it's kind of funny, actually, about my mother-in-law in Echo Show. And the family has multiple connected Echoes, and she saw a reference to do something, which is actually talk to, it's called drop-in, talk to another Echo, like walkie-talkie, across the room. And that caught her eye. Like, what is this? What do I do here? And we talked about it, and it worked. The point is that is what we're talking about here. That is the Echo Show trying to get you to understand how powerful it really is so you love it more. Personalize is an example of what can be used to bring up those features. So you've got a list of features that are brought into it, and then user activity of what features they've already touched. And then Personalize can go back and say, this person happens to like music, happens to like photo albums. Here are features that they haven't touched in this area that they may like. Non-IoT examples, so you can also wrap your head around it. Domino's Pizza used Personalize. They actually came to reInvent last year and gave a talk about it. And they used it to anticipate your favorite pizzas based on your previous browsing history. And it was really effective for them. Again, so effective they came and spoke about it. So that's an example of how it works, but just think about through that. Whatever connected home things you're looking at doing and building, this might be a useful tool for you. Okay? To be clear, I'm not in any of these teams. I'm not on the Pinpoint team. I'm not on the Personalize team. I'm not SageMaker IoT. As a architect, I put them all together, like parts of a recipe. So when I say they're awesome services, I'm not patting my own back. I'm a fan of what these guys have done, to be clear, these people. So, all right. Now, one more thing as I finish. It's now a handful of minutes left. I'm going to pop back and focus on the machine learning here. So the AWS IoT services, again, bringing the data in from the IoT device, if there's one thing that I could just try and encourage you to do as you build your architectures, as you build your devices, it is to collect data, analyze data, and work on understanding your users. That is what's going to differentiate you. If you're just a light switch as an IoT device, that's great. But if you're going to build anything that's of any nature, where there's multiple data points other than off and on, and who's using it and different profiles, bring it in. Also save it. Don't get rid of it. Don't throw it away. Because the ML models you use to train on data today are not going to be the ML models you use 5 years from now. I guarantee it. And you will have regret if you've lost data and your customers are doing something that you wish you had saved that data for someone comes along, some data scientist in your team comes along and says, hey, if we had this, we could have created these new features that we don't have now. Or even worse, your competitor has that data and you don't. And your competitor is able to engage with users in ways that you can't. So save the data, collect it. And I'm not going to go through this list. I went through a handful of them. But the point is, look at these services because these can make the difference into how you interact with your customers. Obviously, AWS IoT and the services there are amazing and they create great relationships between the device and AWS. And then go to the next level with ML. Just point out a few of them, for example. Talked about personalized, talked about SageMaker. Comprehend. If you don't know what comprehend is, if you have a text relationship with your users where they send in a message, let's say they type on the device, or they text in a message with SMS, or they email a message in to your support, comprehend is being used to analyze the text and come back with topics that the user has talked about, but most importantly, sentiment analysis. Is your user upset or not? And when we're talking about predicting to churn, upset users fall into that category. So comprehend will return back when someone sends a text in. You could even have it analyze tweets. If you go to GitHub, type in comprehend, you'll see that we have solutions out there that look at Twitter and can look at the tweets of your company and come back with Twitter users who are unhappy versus happy. And very similar to my demo here, it'll make a segment in Pinpoint so that you can reach out to your unhappy Twitter users if you can map them to email addresses. And Polly for creating voices, and Lex for creating bots. Lex is actually a play off Alexa. So the engine that powers Alexa is available to you. Not Alexa's voice, that's unique, but the engine and various voices as well. So if you want to build bots with your devices, you can use Lex to do that. Very powerful. Okay, and a few more that came out. Fraud Detector, which I haven't played with, but take a look at these. So I encourage you to invest some time. And to that end, I'm going to go back to my slides. So I've gone through demo 1 and demo 2, those my two back-to-back. So AWS has training, not just in IoT. This slide is about IoT, and we really encourage you, though, to take advantage of our free training. Your success is our success. Your frustration prevents your success. So we want you to, that's what reInvent is for. We want you to get this stuff, get as much information as you can. So I encourage you to take a look at AWS.training, look at the IoT training, look at the ML training. It's great. It's the same stuff that we use, by the way. Us as AWS employees, you're looking at the content that we use to learn. And boy, do we have to learn. Every reInvent, everyone in the world is trying to figure out everything that's there. So great resource. Use it. It's worth so much money to you, by the way, when you think, and again, it's all free. Okay, so I'll end with that. If anyone has any questions, we're at the end of the session now, but I'm going to be available to answer if you have any as well. So thank you very much.